Yeah, my name is Kumar. I have around 18 plus of years experience in solution architectures and consulting. So worked in various MNCs. Mainly, I was mainly the domain sector. I was working part of retail, CPG, telecom, insurance, healthcare. So I also started my career in Java J2E and slowly adapted to moving to SOA architecture, data engineering, cloud computing, microservices based architectures. So I predominantly work in these areas. Yeah, that's all about myself. Yeah, over to you, Pravin.
Thank you. Thanks, Kiran. I appreciate that. Moving to the next part of the webinar, as I mentioned, right? So we'll be discussing 3 different stages of the architecture, like starting from the MVP. Like being in this field since more than 16 years, I know I get different kind of customers and different kind of needs. So definitely we'll be starting with whenever we get a requirement from any startup who is in idea stage. So they basically come to us and then tell okay, this is kind of idea we have, right? And we want to build a MVP as soon as possible. That's kind of everyone's wish. And but again, there are a lot of things that comes into the picture specifically when it comes to the healthcare application. So it's very important to take a right decision at the start of the product before we start coding. We need to make sure that the architecture that we're going to plan for the product in the initial stage is in terms of security and compliance is taken care. Otherwise, what happens as you grow, as you get more customers, because that time the HIPAA plays an important role. So we'll discuss more about that in the next slides. So one of the questions that always comes to in terms of solution architecting, right? So for example, Kumar, who comes from the 18 years of background in his career, and then he since few years he's working on the solutioning side of things. He of course definitely worked on a lot of different domains, but healthcare is one of his forte, and that's where a lot of challenges comes when we start building different types of architecture for different types of domain. But when it comes to the healthcare, there are specific questions. There are some things that we need to make sure that we are doing it correctly, right? So there are a few aspects, a few areas that, as far as my experience is concerned, definitely common things in every domain, right? So what kind of users you are expecting? So that also affects your architecture. How much latency needs, request and response latency the customers are expecting? Because some of our customers are having strong SLAs with their customers. With even one of our customer has 50 millisecond P99 requirement, where your 99 request should be finished within less than 50 milliseconds. And that's kind of considering the complexity of the application and whatnot. So we have to make sure that we are actually adhering to those SLAs. There are other areas also when it comes to architecture. So there are some important factors which plays an important role as well. So Kiran, what do you think? What other areas do you think, based on your experience, plays an important role when you are actually starting building the solutions, right? And I believe when you're interacting with the customers in initial stage, or in discovery call, or in even initial what we call design sprint, where in initial requirement gathering stage, what are the crucial questions that you always ask to those customers?
Yeah. Yes, Pravin. So mainly the thing is, so whenever we take the requirements, so the requirements are being broadly classified into 2 parts, mainly the functional requirements and non-functional requirements. So functional requirements are helpful mainly for meeting the business needs and delivering as part of that functional requirements. And non-functional requirements are the key decisions, or the key driving factors. So that makes an architecture to be built, starting from the base architecture to the final architecture. And in the part of non-functional requirements, so mainly from the business or from the customer. So we should be knowing about so what is the volume? What is the volume of the users that are accessing the product or the application? So for example, so based on that, the architecture is being considered in such a way. So where these non-functional requirements mainly on some key terms like scalability, availability, reliability, resiliency. And I'll be talking about the other non-functional requirements like security and performance also. So first we have to consider this. So what is the volume of how many users are going to access the application? So the total user base. So say for example, if that product is going to launch or the application is going to launch in the market newly. So we have to see like, so since they don't have the current user base going on. So the estimate, so for example, within 6 months, what is the user base? And after 6 months or within 1 year or after 2 years, so what is the projected growing user base of it? And so based on that, so we will be planning the capacity of the systems that will be hosted for this application of product. And in addition to that, we are also actually should know about the concurrent users, the number of concurrent users, the expected concurrent users, which we consider about the peak load, because especially this is the driving factor where, so during the peak load, we should, the architecture should be in such a way, or the system should be in such a way, it should not degrade the performance of the application or product. So we should know about the concurrency or the number of users at a time they are accessing the application. So which we call it as a peak load. And based on that, so these are some things. And then what is the expected? So generally, as per standard, we go with the request response times. So as per common applications, we'll be having request response time should be less than 1 second. If it is an online request or response, if it is a batch request response, it should not exceed more than 10 minutes, like that. So we have that kind of scenarios, but again, we should actually get these details. We'll be getting these details from the business. So what is it expected? Because actually there are some applications, for example, where the customers will expect like within 100 milliseconds we should get the request response, because their application can be highly transactional based applications. For example, if we can consider like an e-commerce based application or a banking application, so where the response should be within less than 100 milliseconds. And coming to the healthcare based applications also, so where actually if it is a kind of where there is a requirement for online health monitoring related systems. So even those are all highly transactional based applications. So even the customer expects with very less latency, the request response time will be baseline. So considering this request response time, number of users, the number of the peak load, then we design the capacity and also the thing is we'll not consider the entire capacity at one stage, because as I was telling, we'll consider the initial user base and then the projected user base, and based on that we keep on ramping up our system capacity. So those things, and apart from that, so mainly for healthcare and banking domains, we will be considering about the security. So we also need to consider about the security. So these are the main things that we consider for these architecture relations.
Rightly said, Kiran. Kumar. So basically, even I believe like there are some customers, they have some compliance needs, right? So the audits happen, and then we need to make sure that our servers, right, or even the infrastructure is pretty much secured enough, right, with the compliance needs. Specifically when it comes to HIPAA as well, right? So AWS has that ABA agreement in place, and even like we have to make sure that everything is planned as per the compliance that is needed. But by different domains, of course, healthcare, HIPAA is in healthcare, but there are other compliance needs as well. One more thing.
Yes, right. Yeah. Yes,
correct. Right. One more question, Kumar, like on this side, right? So I believe there are some customers, they even like we need to ask about the monitoring needs. So there are different types of monitoring, of course, but those are also important aspects, right? So what type of monitoring we need, whether it's log monitoring, whether it's performance monitoring, and like proactive alerting and whatnot, right? So I believe those kind of discussions are also happening when you're doing the discovery.
Yes, rightly, Pravin. The thing is, these monitoring aspects. So as part of the thing, so this monitoring can be included as a separate activity, and even this monitoring can be as a part of security also. So when you are telling about the compliance, yes, for healthcare we'll be having this HIPAA compliance, and even for financial sectors we'll be having the banking related proprietary related compliances. And when we consider these compliance issues, one of the key factors that we consider is the auditing actually. And auditing is again a sub-solution as part of monitoring. Like in this auditing, will be mainly tracking the logs and who has actually accessed the systems, and is there any actually a legitimate user or accessing this. So we'll be logging all the tracks. So at which time. So this is a part of one monitoring session. So that will be included as part of security. And separately, if you need to monitor, so that is actually as part of the performance related things. Say for example, so the scalability. So where we include for that is for auto scaling. If more traffic comes, so the auto scaling will ensure that it will actually scale out the nodes, the servers, and everything. And in regard to this, even there are kind of an alerting system also. So in case of any errors that are occurring, so that the system will not be degraded. So these alerts will actually immediately intimate to the development team or intimate to the users so that they can take the actions appropriately in the proper time. So these are the things that we consider as part of these monitoring solutions.
Right. Good. Great. Yeah. Thanks, Kiran. I think one of the quick thing that came in my mind recently when I was speaking with one of the customers, their compliance needs was like having an archival system, right? So whatever files they have to archive for, let's say, 10 years. And then after that we can delete. So we need a proper strategy for that so that the cost will be also served. Like, for example, AWS has that archival stuff and that is very cheap, right? So the proper strategies in place are going to play an important role, not only in terms of the compliance needs, but also for the cost savings, right? So that the business doesn't suffer from a lot of cloud costs.
Exactly. So the same will be applicable for these logs and audit trails also. So if you need to maintain the historical data, so going with the primary solutions for the log data source will be costly effective. So we can maintain last 6 months or 3 months of the data, and then we can use these archival systems for the retention policies.
Exactly. Great. So I'll move to the next slide. So this is more like Kumar, like we discussed, like there are 3 different stages of any of the product, right? Mostly these are the 3 different stages. What we think plays an important role, starting with hypothesis, then we have growth stage, and then establish where like actually a product is scaling and scaled, right? So definitely there are different needs at different stages. And there are different architectures at different stages as well. Of course, we cannot plan for the scalable product from the day one and then spend a lot of time in re-architecting. Then our time to market will be slow, right? So for any startup, it's very important for they have minimal architecture at the start with the compliance needs and whatnot. But at least that should work, so that they can test out the water, they can test the market out, and then slowly they can, when they have more customers, they can definitely change the architecture and then move to the with the microservices or automation on pipeline and whatnot, right? So I think, Kiran, like you have been part of the different solution at different stages, right? As me does. So what are your thoughts for what do you think, what are the important decisions that you take, or how you take those decisions at different stages? Of course, I know you, when in discovery call, you ask the questions, what exactly the expectations are, but at high level, what do you think, which is a different stage, what kind of architecture one startup should have, one product should have?
Right, Pravin. So I'll tell about my experience that happened a few years back. So when actually I was working for a product-based startup, so it was actually the new product that we were working. So at the time, they wanted to readily go within 6 months, at least as a minimum viable product into the market. And then they ought to see their potential user base. And based on the revenues that they get after 6 months, so then they wanted to scale this project. So what actually I planned is if we start sitting about looking up for the extension of the architecture or scaling up the architecture, the time will not be sufficient. So what we went is as the first stage, which is the hypothesis that is mentioned in this slide. So we went with a very bare minimum layered architecture. When we say bare minimum architecture, so as everyone knows that there is a ABC of an architecture. So which we call it as a model 2 architecture. In the typical MVC areas in the olden days, where we call it as a classic model 2 architecture. So with the simple UI, which is a front, which is a tier 1 layer, Next, tier 2 is a service and backend layer, and tier 3 database layer. It's a simple model 2 architecture. So just with that architecture, so we immediately fit up the components where to be fit in UI, where to be fit in the service layer or the middle, the tier 2 layer, and where to fit the database, the data, all the entities in the tier 3. And we started developing that, and we went within 6 months because we did not spend hardly we spent just 2 or 3 days in just preparing that model 2 architecture, the old classic architecture, and then we started. And it has helped that startup actually very well because we have taken a right decision without spending much time in that architecture, and start immediately coding and testing and pushing that to the production environment. And then they started looking about the user base, and they started seeing some revenue in their things. And then after the eighth month, actually, that means once the product has been moved to production, after 2 or 3 months, again, I got a requirement like, now why can't actually now we enhance this? The reason for enhancing this, now user base is increasing, and whatever we got with model 2 architecture is we have gone with a single server, just like it's a plain single server, single node, even it is not a distributed computing. And then now user base is growing, not only for the product in India, even at the geographical locations. Mm-hmm. So then they started seeing the growth of that. So then what actually, so I planned is where now instead of single node, why can't we go with it? We can go with a distributed node. That means the code base is still the monolithic. When we say monolithic, all the functionalities are embedded or put in one single code base. So it can be called as a var file or a jar file in terms of Java technologies, and that can be deployed in the production server, and it can be executing. So in the growth phase, how we planned is, okay, so let us not touch the code, because if we touch the code, again, it will be a very huge requirement. So let us now plan at the capacity level, at the infrastructure level. So why can't actually now we scale out the nodes instead of single node? Why can't we scale out the nodes? And we actually set up in horizontal scaling and with a proper load balancer. And initially we have, this product has been set up initially in the AWS cloud only. We use the same AWS cloud. Only thing is we depended completely on the infrastructure as service, where we use EC2 instances, right, and everything we have set up manually. And so the traffic started coming, and at the 8th month or 9th month, the traffic started coming, and then the application was also well scaled. Now, the thing is, now the application is scaled well. Now that there is no performance issues, there are no scalability issues, because the application is deployed in multiple nodes in a distributed computing with a data store. Now the thing is, now the functionality started increasing actually. So the functionality started increasing, and different users, say for example, few set of user group, they wanted to access a kind of, say this is a kind of actually we can say a recruitment platform. So they wanted to access an assessment library related, and few users wanted to access the job listings related things. So different user bases wanted to or cater to multi-specific functionalities, and thereby the new functionality started keep on coming. So then what actually we planned is, so that was a monolithic. So why can't we take these new requirements as a separate modules or separate services? Because this is following a SOA model with exposed as completely web services. So why can't we actually take this service-oriented architecture and refine this to granular services? And that evolved actually for us to enter into the microservices-based architecture for this product actually. So how we planned is actually, so the monolithic architecture, existing monolithic architecture, initially we did not break that, but what we did is we keep on adding the new services as a separate microservices. And so we developed a pattern called strangler pattern. So what the strangler pattern will do is actually that will actually redirect the request to the new services or redirect the request to the existing services based on the user request or based on the user path that is accessing the functionality. So like that actually, so we have broke that monolithic to microservices based architecture, and we were able to scale well. And eventually, once we started microservices-based architecture, eventually this product where we are using infrastructure as service, we eventually moved to managed services as a platform as service with containerization approach, because every service will run in its own container environment, and that made the architecture established. And any new functionality we did not touch the existing functionality. We developed a new microservice and posted there. So, which has actually led to the scope of high extensibility and high maintainability of the architecture. So, in that way, for the same product, we have seen 3 different stages based on as the time period grows, as part of the product grows, as part of the user base grows, and as part of the functionalities grows.
Mm-hmm. Awesome. Okay, great. That's great to hear. So the quick question from my end would be, right, so there are basically, as you mentioned, the geographical location is also an important factor when you're in different stage, right? When you're in growth or scale stage, I think people from all around the world will be accessing your product. So at that time, it's very important, like high availability, like CDN, those factors plays an important role, right? So at what stage you had taken those decisions, in like growth stage or in the scale stage? Or when should any startup should think about it?
Yeah. So when we consider about this high availability, scalability, in the growth stage only we started planning actually. In the growth stage, actually, say for example, at different geographic locations when it started, so then we started implementing this content delivery network (CDN). So that serves for the static content very fastly, and even for high availability, scalability also, the growth stage we planned. But in the established stage, once the new requirements started coming, new functionalities are being incorporated based on the business revenues, based on the business requirements, then we started splitting that monolithic to microservices in the established phase actually. But the availability, scalability are well planned from the growth stage.
Got it. Yeah, totally makes sense. For sure. So now let's go to more like kind of a deep dive of more technical architecture side of things, right? So like let's go through one by one for each stage, what 3 stages we discussed. Like let's try to understand like each stage of the architecture and how one should plan for it, right? So I'll move to the next slide where we'll be speaking more about the MVP, right? So bare minimum architecture, that word that you use, right? So can you explain a bit at low level now how exactly it is planned in your case or in some of the products that we built, and how one should plan as well in their journey?
Yes, Pravin. Actually, so when we started this architecture, bare minimum architecture, so the focus will be put together to all the basic elements that cater to this bare minimum architecture, and when we started actually implementing this architecture and move to the production, so initially there are 2 stages here. One is alpha release and another is beta release. So in alpha release, what will happen is we will not consider much about the security or will not consider much about the reliability. It is only in alpha release the developer who is going to test that alpha release actually. So mainly, so the development team will ensure that all the functionalities are met in this system, including the NFRs and everything, including the functional requirements and non-functional requirements. That is a part of alpha release. And once this alpha release has been planned, so then it will be moved to the beta release. And in beta release, it is as if actually it is working as in we can call it as a prototype to the real entity. And this will be tested by the real-time the customers. Beta users and the real-time environment. And here we consider all the aspects for security, compliance, and reliability and everything. So when I say reliability, so reliability should be the outcome of, for example, so mainly when we consider if the system is down, so mainly we consider RPO and RTO. So where in RTO we consider in how much amount of time the system will be back or will be up and functional. And when we consider RPO, in case if the system is down, so we need to consider how much is the loss of data. So that means data backups are also very important actually. And since in case if data server crashes, we'll lose the entire data. So the frequent backups And for example, we are taking a backup at morning 10 a.m. and the next backup is around again after 11 a.m. Say at 10:30 a.m. the server got crashed. So what used to happen is 10 to 10:30 a.m. data will be lost actually. Okay, so those kind of scenarios are all we have to consider when we just from beta release when we move to production, actual production. So all these things we have to consider in beta release and properly plan and then move to the production. So though these are all part of MVP, but these are very essential, especially from the reliability perspective and resiliency perspective. So many people will get confused about the difference between reliability and resiliency. So I want to tell you in this webinar. So reliability is actually the outcome of what I have told actually, mainly how we can achieve. So what is the RTO value? What is the best RTO value that we can achieve? What is the best RPO value? That means when we say best RTO value, decrease in the time where the system can get to normal state. And the best RPO value is decrease in the time where the data backups will be very frequent so that there will not be huge data loss actually. And in order to achieve these, so we'll be implementing resiliency factors. So that means reliability is the outcome and resilience is the way to achieve this outcome actually. So mainly for resiliency, for example, when we say, let us take this MVP. So many people will get doubt that in MVP, what actually resiliency will be considered because it's a minimum viable product and only one component will be running as a whole as a part of a single application. Yeah, correct. But within that component, say for example, say let us go to a simple three-tier architecture where we have a UI, where we have a service layer, and where we have a data layer. Say for example, in service layer we have two instances of service layer running. So what happens actually if one service layer is down? So more traffic will go to the one service instance, and the other service instance is completely in the
idle
closed state actually. So resiliency is a way where there should be some self-healing capabilities where the system should heal itself and then it should come to its normal position. So if we can implement this resiliency, then automatically reliability is achieved actually. So in that way, this resiliency and reliability are interlinked to each other. So these are all we consider in the beta release. Okay. So the next slide, if you see Pravin, which I was talking about the alpha release. This is actually where we do in the pre-prod environment. Mainly it is done by developers. And mainly here we don't consider the reliability, security. We'll consider here all the functional requirements are met actually with the basic non-functional requirements. But all the functional requirements are tested completely in alpha release. But in beta release, we focus because once alpha release, all the functional requirements are tested. Then we move to beta release, and in beta release, we test mainly the non-functional requirements. So the security aspects, the reliability aspects, and everything. So in this way, either it is an MVP or it is a large-scale product. So when we start adapting to the production environment, so it has to move from alpha to beta and beta to the actual production. So in that way, we design all these actually.
So just to confirm, right? So in the alpha release, you mentioned that the compliance and the security needs are taken care.
Yeah. So here in alpha release, mainly the focus is mainly on the functional requirements actually.
Okay.
So on concentrating the functional group, but in beta release, we take the complete security part, compliance part.
Including the non-functional.
Yeah. And when we say compliance means, again, here there are two things. Compliance at the infra level, compliance at the code level. So compliance at the code level will be taken care of by the alpha release, because alpha release will freeze the code once it moves to beta release actually. Almost it is freezed whenever we want to change something. So in alpha release, what will happen is, so when I say compliance at the code level, say for example, let us take healthcare HIPAA compliance. Say the PHA data has to be, when we log some information to PHA data, so what will happen is at the time of development only, before moving to pre-prod development, so our code should ensure that we should not log as is the PHA data, which actually violates the HIPAA compliance. The logging we should have some masking. We should have masking of that using some mask converters, and then we should mask the data by logging, so that anyone if monitors the log, So so all that will be handled before alpha release. So that is for sure actually. Okay. Because actually in beta release we might miss all those things. So in beta release we mainly concentrate at the infra level actually. At the infra level, the security is performed. Even for example, the API, the request response, the security scans, everything are performed at the beta level.
Great. So I'll take one question from the audience, right? So it's related to what you're speaking about. So when it comes to PHI data, right? So most of the time, the customers are worried because their engineers are working from different locations. There are offshore teams, onshore teams. So from the infra perspective and the compliance perspective, what are the different ways to prevent that PHI access from the developers? So for example, because the production, if there's something happens and you need to like reproduce something, some issue from the production, so you have pre-prod environment, which is kind of a replica to the prod, I believe. And then in that case, what are the best practices one should follow to make sure that the PHI is not accessible by the developer?
Yes. Yes, Pravin. Yeah, this is a good question. So mainly the thing is, we follow certain aspects. So mainly for PHI data, there are two things we have to follow. So encryption at rest and encryption in transit actually. So that means, so when the data is stored in the data stores, so all the data should be encrypted. And even when the data is in transit between the source to the consumer or consumer to the server, or between provider to consumer or consumer to provider, so the data should be encrypted. So the basic things that we have to take care of is while data in transit, encryption at transit, so the data should be, it should transport over to its SSL layer, which is HTTPS. So HTTPS is compulsory there. And even actually when data is at rest, we should follow that data stores. Either this encryption can be applied at the application, and again that can be stored at the data level, or at the data level itself, there should be an automatic mechanism that encrypts the data. So if we use this cloud managed services, by default, there are some data stores, not some data stores, even many data stores. So they follow this encryption policy when the data is at rest. Right. So that is one thing. And another thing is the custom managed encryption. When the custom managed encryptions at the application level only, we can encrypt the data and then store. That is one thing. So again, when we say custom managed, so there are different approaches for this. One is using the plain typical encryption algorithms, strong encryption algorithms. That is one thing. Or another thing is the tokenization approach actually. And this tokenization approach is predominantly followed in healthcare sector and in banking sector, where the tokenization will what we say is it will actually convert actually the sensitive data into a particular token that cannot be interpreted by any legitimate user or any intruder actually. So this is what we call it as a sensitive data array. In healthcare, if we say it is a PHA data, or in banking financial, it is a very financial sensitive data. And this tokenization server, what it will do, there are two parts here. One is converting the PHA data to or sensitive data to token, and then bringing back the token to normal data. That is another thing. Right. So that is one way of which we call it as a tokenization.
So, sorry, go ahead. So I was just asking the related question because AWS has the KMS, right? So this is like kind of a key management service which helps in encryption. So where it's places, like it's a tokenization service, or like which one do you think is like KMS is suitable for?
Yeah, we can leverage at the tokenization service, or even we can leverage if you want to implement our custom encryption algorithm also. So we can actually generate our own keys and take the help of KMS to manage those keys actually.
Right. Okay.
And yeah, so that is what we protect the data at the rest. And the another thing is actually another important factor is actually authorization. Authorization and authentication are most important. So we should allow only the authorized users to access the data. And one more thing is the data stores whatever the data stores that are there, they should not be exposed directly to the public network. So there should be in a private, for example, if you take an AWS cloud or any cloud, so they should be in private subnet actually. And the data stores storing this PHA data should be accessible only from the applications. And that too, these applications should be in the virtual private network of the particular organization, and they should not be outside virtual private network, and these should be in virtual private network, so that the proper only the proper network access or proper whitelisting of the who are supposed to access everything can be controlled from this firewall system. So that is another way. And so there are different ways. And then another way is actually we can actually we can implement the filters of interceptors. Just like in AWS, if you see, we have this kind of shields and everything. Mm-hmm. So even actually, if we do DOS attacks or anything that tries to access this PHA data, so we can prevent this, we can intercept these data and then reject this data without forwarding this request to the application servers.
Right.
So yeah, these are the things. And even there are some things like we can implement even this AI/ML approach also to predict actually the faults that are occurring, the future faults that are occurring based on the patterns that we observe when we log using the cloud audit trails or audit logging at the API level actually.
Right. I think so that is like a managed service, right? So AWS.
Correct.
Right? Yeah.
Yes.
That's good point.
Yeah. So these are the things that we use. And even the compute servers which are actually running, so they should be in a private, they should be in a virtual private network so that no one can access the compute servers directly. And the compute servers, the data servers, everything should be in private subnet. Only these servers should be accessible either through a normal bastion host from a public subnet or through a load balancer that is hosted as a part of public subnet. So in this way, we can prevent all this data without being taken as a fraud or without being taken as a corrupted in this way.
Right. No, those are all great points. So there are some things definitely like the audit trails are very important, which plays an important role in specifically in healthcare, because I remember there are some incidents where like there are access to S3 objects happened, and then as per the audit, like they want to know who accessed this file, right? So definitely if we don't have that audit trail in place, there can be an issue. That's
yes, correct.
Yeah. Yes. Moving to next slide. So now like in the growth stage, right? So when it comes to the growth stage, we have different architecture now because the product is scaling. You are now like seeing a traction, good amount of users, paid users you're seeing. We had a monolithic architecture, I believe, and even like you mentioned in the initial stage, of course, there are small servers, so one server without load balancing, and then all the requests are coming there, right? It's a monolithic application. So now like in terms of growth stage, how you see it, right? So now, of course, we're building the product. We need to, as you're seeing the users, the tractions, now we can't go back and like throw it away, everything and restart. That is not an ideal way. So now we have whatever we have to build on top of it right now when it comes to scaling. So what are the best practices one should follow when it comes to the growth stage? So considering like they have the initial version built. So what do you think, like now in the growth stage, what are the focus areas?
Right, Pravin. So mainly we have to, once the minimum viable product of the initial version has been built, now definitely the product keeps on growing and different features or different enhancements are being added. So we have to follow certain deployment strategies. So before actually finalizing the new version, because the old version was a stable version and it was running in production from many months or from many days. And the new version, immediately we cannot actually replace with the old version as a whole like that, which will impact the things, though we tested thoroughly in alpha release or beta release. And so what we can do is, so we'll follow these deployment strategies. So this is what we call it as a blue-green deployment. So in blue-green deployment, what we do is, we take the beta release and so we actually eventually split this to blue and green. So blue will be as a part of, so we can choose anything actually, either blue or green. So the new version can be a part of blue, and the old version can be part of a green. So that when I say the new version, the beta version is moved to blue, and the old version is green. So the traffic will be moved to green. Now,
So
what
this
we
is
do
kind
is
of a stage release, right? If I'm not wrong.
yes,
Yeah.
yeah. So what we do in this blue-green deployment is this will be applicable for pre-prod, and this eventually will move to prod also. In prod also this will be applicable. So in prod, how we do is actually there is another scenario for canary testing. In prod, how we do is so we'll have both versions at the same time, the old version and the new version. And so the new version, the old version will have certain amount of traffic, okay, and the old version also will have certain amount of traffic. So what will happen is when we see that, so once we test thoroughly the new version, so then we'll make this new version to be the final version. So that means what we say is it's blue-green deployment, and the next slide we have is a canary deployment. This can be combined as a whole actually. So in blue-green deployment or canary deployment, we split the traffic, and then we eventually see, say first we'll start with 10% traffic to the new version, 90% traffic to the old version. Then we started slowly moving to 20% traffic, then 80% traffic. So like that. So, and once we have all these things, and once we see that 20% traffic of the new version is working properly, then we promote that, and slowly we make that as a final version. So in this way, actually, these things are being done. And yeah, initially this started with pre-prod, but nowadays actually even production environment has also been incorporating like these things.
Okay. Okay. So are there any out-of-box solutions available, or the AWS provides any kind of a blue-green deployment services, or like we have to write our own? For example,
yes,
like the traffic rule, right? 10%, 90%.
Yes, yes, Pravin, actually, yeah. So if we take this, if we can use this Route 53, Route 53, right, where we can divert the traffic with weighted balance. That is one thing. And another thing also we can use Istio as an ingress service, right, where we can route the traffic between the primary and the second. Right. I mean, between the old version or the new version. That way we can.
Makes sense. Yeah. So Istio is open source, if I'm not wrong.
Yes, yes, yes.
Okay. So I'll move to the next slide.
Yeah, this is also, as I was telling, this blue-green and canary deployment can be combined.
Yeah, this is where the weighted load you have shown.
Correct. Right? Exactly. Yes.
Okay.
Yeah.
So this is now like for the last stage, right? The stage.
Last stage. Yes. Yes.
Now we are talking about a lot of scale. People are like there is a concurrent transactions happening, right? And now we are not only worried about the scale, but also we need to make sure that there might be a security issue. Like even the attack can also consume your resources. The DDoS you mentioned, right? So we need to like make sure that everything is in place when you're actually scaling. So that strategy we have to of course start that planning. We have to start in the growth stage itself. But what are the different differences that you see when it is actually scaling compared to the growth stage? Are there any major architecture overhaul we need to do?
Yes, yes, Pravin. Say when I was telling from growth to established, so we see eventually from gradually increasing from monolithic to microservices. Yeah. There might be a question that it is a compulsory to use microservices in all the architectures. The question is no, actually. Again, it is not compulsory to use microservices in all the architectures. Since we know microservices, we can't directly do microservices. Mm-hmm. So we can say like this, say, for example, one monolithic is equal to one microservice. One monolithic is equal to many microservices. So like that, one monolithic can be mapped to one to many. There is a relation between monolithic to microservices, one to many microservices. Mm-hmm. Now, so when we see the mathematical model of these microservices, we can split this into three-dimensional things with an x-axis, y-axis, and z-axis. Mm-hmm. And say, for example, as I was telling you, one monolithic can be one microservice, or one monolithic can be equal to n microservices. Now, let us consider, say, for example, one microservice. Say, let us take one monolithic is equal to one microservice. That means if I deploy one monolithic means it is equal to one microservice. Now in x-axis, what we do is we horizontally scale the instances of the microservices. This is because to distribute the load horizontally. So as I was telling you the incident of the product startup. So we started actually horizontally scale to increase to meet the traffic load, so that the performance of the scalability of the application started better.
Yeah, so compute you're mostly increasing horizontally.
Correct. So that is what we call it x-axis. Now, so the instances are split across a horizontal x-axis. Now, what next is now functionality keeps on increasing. Now functionality starts. So now why can't actually now I split this single monolithic to multiple microservices, each microservice catering to one function. So if you take a typical healthcare application, so say for example, patient-related functionality can be one microservice, doctor-related functionality can be one microservice, security itself is one microservice. So like that, we can split that into based on the functionalities we can have. So which is actually catered to y-axis. Now again, so these microservices, which is at the y-axis level, there's functional split. Now what about the data? So now do we need to partition the data? Say for example, why can't actually the particular patient-related microservice can access only the patient-related information or patient-related data store? Why can't actually the doctor-related can store only the things, or anything related to order management of healthcare instruments? So that why can't it access only the particular instrumental-related data or the order-related data? So all that actually is part of the z-axis data partition. So in that way, so we start with scaling the horizontal instances at the x-axis, and at the y-axis level, we split that based on the functionalities, and at the z-axis, we partition the data which caters to each microservice. So this is when we take this as a mathematical model, we can visualize like this.
Right. Okay, so that is like kind of an interesting thing, right? Basically, when you're talking about data partitioning, each microservice has its own data store, if I'm understood correctly, right? So in that case, how exactly the relations are meant? Like, is there any chance of data duplication here? Like,
yes, Pravin. Yeah, that is one very interesting question, actually. When we split the data as a partition, the data model has to be designed very carefully. So because unlike in single database where we'll have multiple tables and the relationship between the tables with the foreign key, child key relationships and everything, all that cannot be achieved when we partition the data, because the tables will be completely now, we cannot follow the exact normalization that we follow for RDBMs. So now all the data, for example, let us take the patient-related data will be stored in particular patient data store, and the doctor-related will be stored in. So like that, we'll have the complete data partitions. And when we design the data model, we should be very careful in such a way that dependency should be in such a way they should also follow all the transactional based capabilities. When we say transactional based capabilities, say for example, let us take in healthcare, the patient related information associated with a particular doctor, is there actually. So what will happen is I'll be having patient related information, one data store, doctor related information, another data store. The relation between these two is that patient will be associated with a particular doctor. So that means one patient to one doctor, like that. So, but for one doctor, there can be many patients actually. So what will actually, we should have a primary entity at the things, but whenever any request that comes for a doctor related microservice, so that request has to fetch the data from the doctor related data store, and at the same time, from the doctor related microservice, it has to call internally the patient related microservice to get the patient related information.
So it's inter-micro communication, right?
Yeah, it is between the microservice to microservice communication. And we also need to ensure that the transactions are also proper. Like, for example, if the patient complete information is deleted, then automatically, or for example, if the doctor related information is deleted, then we should be ensured that the patient associated with the doctor also should be deleted, so that the patient can be mapped to another doctor. So in this way, the transactions are to be managed very properly. Actually, for that, we can leverage some of the patterns like event sourcing patterns or messaging patterns, where any deletion or updation of the doctor related microservice will trigger an event to the messaging queue. so that the patient-related microservice can consume that event and can update the patient-related data in such a way.
Exactly.
So like that,
this is kind of asynchronous, yeah.
Yeah, it should be asynchronous. So like that, the transactions is also good. See, this is what we call it as a distributed transaction management. There are different ways to achieve distributed transaction management, especially on the microservices level. So one, we can use the old way where we used to use JTA, which we call it as two-phase commit protocol, which we call distributed transaction using JTA.
Correct.
But that was actually a legacy approach, and it has led to performance implications. Then we can use, in the microservices world, we can use Saga patterns. That is one way, or messaging queue patterns is another way. In that way, we can achieve all these transactions, especially when the data is partitioned across multiple microservices.
Considering, because we have different ways to handle the situation right now, like considering the security compliance in healthcare products specifically, because when we introduce more data stores or more service or systems, right? So, because for example, like if we're talking about event driven, then you might be thinking about the SQS, right? Or when it comes to the AWS. Now, like the queue is also storing some sort of data. Now, again, we need to take care of the HIPAA that side. So, like
exactly, Pravin. Exactly. Yeah. Yes.
So, does when we are architecting, right? When you're actually building, solutioning these kind of a product. So, what is the best way to go with the plain approach, microservice to microservice synchronous communication, which doesn't store anything? Or you think okay, maybe we have to decide it carefully, understanding the PHI side of things, and then don't store that on the queue? Or does SQS also supports KMS encryption?
Yes, exactly. So yeah, definitely. So when we use intermediate stores like SQS or Kafka, these things, so they are already they have a mechanism to support data encryption at rest. So whatever the data stores that we are using in our architecture, everywhere at each and every piece, we have to consider the encryption at rest. And as I told you, they should not be exposed directly to the public network, and they should be protected from a private subnet. For example, if you take SQS or any RDS, so they should be accessible only from the VPC endpoints and only authorized users. And even to access SQS we cannot access directly without proper authorization. And the communication with the SQS to the microservice, everything should be SSL layer actually.
Right.
Where is the data interest? So we have to follow all these when we design this architecture. So we have to identify the components where the data is being stored at multiple places in our architecture. And also we have to identify the components where the data is flowing between one system to other system, and how the transport is being done, either through HTTPS or it's a plain TCP. So at all places, we have to follow the SSL mechanisms, so that during transit also data is protected, and during the storage also data is protected at the data stores.
Correct. Glad that you answered that, because that was one of the questions asked by the audience. Audience,
sure.
Please keep posting your questions under the Q&A section. As we get time, we'll definitely answer. And just to let you guys know, one of the luckiest person who has definitely asked the right great question, he will going to get some Amazon voucher. I'll move to the next slide. So again, now this we discuss at high level, but again, you can just specifically put a focus here.
Yes, correct. So these are the things when we consider, as I was telling you, one monolith can be one microservice, or one monolith can be multiple microservices. So when we consider one-to-many between monolithic to microservices, so definitely now we are entering to the microservices-based architecture for definitely high scalability and extensibility. So what are the things that we need to consider? The basic microservice principles like service discovery, the load balancing between the services, not only at the instance level, but within the service level. And as I was telling, self-healing capabilities, when I was explaining about the resiliency through circuit breaker, and the configurations also should be extendable and protectable. And the centralized logging mechanisms, where logging has to be proper as a part of monitoring mechanism. And also while logging, we should follow compliances like HIPAA in the healthcare, where the data is masked properly and all that. So when I say centralized logging, this is the logging across all the services. So these are the things that we should follow while we design this, when we split this into multiple services.
Awesome, great. So I will take one question from the audience. So from Sudesh. So what he's asking, right? So most of the time, like when you were specifically focusing on any of the solution, we are talking about the AWS services, right? Whether it's KMS or CDN, whatnot, right? Now, like if someone is using GCP or Azure, so as per my understanding, there are equivalent services available on the GCP and Azure because they are each other's competitors. What are your thoughts? Like these are like kind of like whatever you're telling is properly, we can easily migrate to GCP if let's say someone is on AWS today or vice versa.
Yes, exactly, definitely. Say for example, when I was telling about the compute EC2, so we can leverage Google Cloud Compute Engine, or when I say about the containers like EKS in AWS, we can leverage Google Kubernetes Engine. And so the key management store at the Google Cloud, we can leverage the managed service at the Google Cloud level. We have an equivalent service even at Azure also, and even at the data stores also, where AWS is providing data encryption at rest. Even GCP, if you go with this kind of Cloud SQL or so there is actually new SQL at the cloud level. So all these are all actually they provide an encryption at rest. Every cloud component that we have, they are equal. They are having equal component. When we come to Azure also, we have protected stores of the key vaults, Azure key vaults, and we have Azure managed services like web apps or Azure Kubernetes services for containerization. So whatever I was talking in AWS, every service in AWS has equivalent in Azure and GCP.
Right. That's what I understood. Okay, let me move to the next slide. So you already had like given some high level idea about like whether you're using a shared database or like data store per microservice, and then pros and cons of each, right? So again, like is like specific to business needs, we need to decide this architecture, or like there are any other factors that you actually take consider while deciding whether we need to go with the shared database or service to service data store model?
Yeah, it is actually as per microservice principle. If the design permits, it is always recommended to go for microservice per database. But there are some scenarios where I have seen some projects where they started with microservice per database, but they could not succeed because as the data model was growing and they were not able to maintain the integrities across the data stores and the transaction capabilities. Again, they shifted back from microservices shared data to microservice shared database model. So like that, so initially they went as per microservice principle, like each microservice for one database. But again, they reverted back to microservice shared database because of their data model and their growing data entities or business requirements did not permit it to scale that to that architecture. So it all depends upon our design, the business data model, and the business requirements.
Got it. So the next slide is mostly again like with the shared database, right? So correct. You spoke about it already.
Yes, okay. Yes.
I'll move to the next slide.
Yeah. So this is one more advantage if we go with this kind of service to service based microservices based architecture. So which we follow this as a polyglot architecture. The technology stack that we decide, we do not focus on a single technology stack. If it is a monolithic complete code base, it has to be developed either in Java or Python or .NET, any component. But here we can now, as I was telling you, as part of the y-axis, we'll split this monolithic into multiple microservices based on the functionalities. So what will happen when we split this into different microservices is we can develop one microservice in one tech stack, another microservice in another tech stack. So like that. So because actually here it is a service to service communication will follow interoperability. Like it is a pure based REST based communication, whether in JSON format or XML format. So JSON or XML is not bind to any programming language. So any programming language can understand this. So I can design the microservice 1 with the Spring related framework. I can design microservice 2 with main stack, microservice 3 with the J2E stack, like that. Again, it depends. For example, I have a microservice that caters to high CPU intensity. For example, let us take transaction-based application, transactional microservices. For example, in healthcare, we get, if it is related to an order-related service, so it is a high transaction-based things, or and even in financial sector also. So that requires a lot of CPU intensive-based application for which Java supports that. And we also need to have a service that performs high analytics with the more input output, leading to scalable data stores, so that we can use for catering to the NoSQL or Spark related Hadoop related microservice. Similarly, we can have the kind of blocking calls which actually doesn't need for that microservice. For example, if that service is having more DB calls or more external integration calls, we can go for single threaded because that doesn't require more CPUs, but it is more high IO intensive application. So for that, we can go for Node.js kind of stuff. So like that, we can decide on which service is even functionally also that is actually possible also by knowing the functionality of the service and by knowing the number of users accessing that service functionality. So we can split that into microservice and then we can decide the tech stack of that service. In that way, we'll have a freedom to use multiple technology stacks. In this way, one limitation is there, one advantage is there. Limitation is we should find the multiple tech stack peoples to develop this kind of things.
That's
and the second way is suppose in case if we have a team with a diverse set of technologies, we can utilize these things in this.
Correct. Exactly. Yeah, I was asking the same question because again, like managing different people of different skill set is again a challenge, right?
Correct. Yes.
Right. But of course, like if the need is there and like if you have the data centric operations, because Python is always good for like related to data or whatever you need to do with the data because it has a huge library support, right? And Node.js is also what you mentioned. Of course, they are based on use cases to use cases. Let's go to move to the next slide.
Yeah.
So yeah, definitely. Like this is more like the high level architecture about like again if you have like scale, right? If you're talking about the scaling or the I think you use different word for that stage. But yeah, I think this is a very important factor, whether it's optimization or maybe making sure that you are very pretty much clear about the functional, non-functional requirements as well, right? So, and you are also like with the business team, you're synced up. So we have to make sure that when it comes to architecture, it's not only about technology. Again, we need to make sure the business needs are met, whether it's compliance and other things, right? So I believe when you are actually asking these tough questions to the stakeholders, at what stage? Like in the growth stage, you are taking care of this, and then you're planning for the next stage. How exactly you're doing it?
Yes. Yeah, definitely we'll be asking these, discussing this with customer at the growth stage, because actually this has to be scaled and this, the product or application is growing based on the user base and based on their business model. These points will be brought. And once we come to the established stage also, then we'll cater about what are the, again, these non-functional requirements and functional requirements are discussed. Starting, say, for example, growth stage has implemented, has met their criteria for 60%. The other 40% will be asking this in the established stage. So where we'll be catering for different optimizations. And based on that, we start with the product at scale, then we make that to, even we'll expose that for partner integrations. And then we take constantly feedback about that with the customers. And all this will be happening. So, but we'll initiate this, we'll start these discussions from the growth phase and eventually continue this till the established phase.
Correct. Okay. Makes sense. Now, like this is kind of a final things at the presentation on the webinar side, right? So now we spoke about a lot about security and compliance, but what exactly at AWS level it look like, right? So what are the different elements when it comes to the security and compliance for the healthcare products, the HIPAA side of things? So how exactly we can map those, right? So for example, like here, what we mentioned, the data, right? So we spoke about data at rest and transit. So what are the services that AWS offers? And just for the audience sake, all these services are related to AWS, but you can find the similar services in Google like GCP or Azure. So it's just like different names, but they do this. They serve the same purpose. So Kiran, why don't you quickly provide us high-level thoughts about each of these? Like, what are these services look like? And I believe these
Yes,
are
yeah.
mostly we need to take care from the day one, right? Because as per the compliance needs, it has to be done.
Yes, Pravin, yes. Yeah, I have seen actually a couple of healthcare projects not following this compliance, though the development team and the management team has spent a lot of effort because of security checks and audit checks from the customer end, that projects did not move to production actually. So at the starting of the project only, we need to ensure all the complaints that has to be followed, especially for healthcare, when we say this HIPAA complaints, when we say for this. So if we don't follow how much NFRs we meet, how much functional requirements we meet, if the compliance is not followed, I have seen a couple of projects in the past where they spent almost 8 to 9 months of effort, but did not went to production. And this has become a huge loss to the implementation team and even for the business also. So we need to ensure that properly all these compliances are followed. And when I was telling about this, first there should be an agreement with the cloud provider from the customer end of point of view, the kind of data that being protected, and we should provide the data related classification to the cloud provider. And then as a whole, AWS itself directly does not tell that I will be protecting the compliance. So that is not the responsibility of the cloud provider.
Correct.
The cloud provider provides a managed service where the application team or the business can utilize these services in order to ensure that their data compliance is not violated. Actually. So AWS has numerous services, and it is a responsibility of the application team or the product owner team to utilize these services and follow the compliance. So for that, for example, when I was telling about these compliances, data at rest and data in transit, so we can leverage the storage related things like RDS, S3, and leverage KMS for the custom management, the managed key management solution for data encryption. And similarly, we can leverage AWS Certificate Manager for the SSL certificates during the data in transit. So when we design the architecture and when we start implementing, so we have to consider these components. And again, whoever doing in the other clouds, there are equivalent components in GCP and in Azure. For example, Amazon S3, we can have cloud storage in GCP and Azure Blob Storage in Azure. Like that in EC2, we have computing engine in GCP and Azure Virtual Machine in Azure. So like that actually. And similarly, that is for encryption. Then another thing is I was just telling about the authentication and authorization also most important. That allows only the authorized users to access the data and prevent the intruders or the tamperers in order to not to access that user data, PHA data mainly. And there should be some proper predefined admin policies also should be defined. So for that, we can leverage AWS IAM that protects the AWS resources for authorizations, Cognito that manages the user pool, or we can even leverage the OAuth 2 related things with certain OpenID providers or the enterprise managed LDAP, yes. Managed enterprise managed LDAP servers that has single sign-on capabilities. That is another thing. And then firewalls and network security is most important at the VPC level, at the VPC endpoints. And I was just telling all the protected data stores, the compute stores should be stored in the private subnet so that no one can access the data and it will be accessible only from the resources that are present in the particular VPC. And audit logs are also most important. That will allow us to monitor the users, and also if we can implement AI and ML, we can also predict the behavior and then we can expect the risk that is coming actually. So for that, we can leverage CloudTrail or CloudWatch, and even we can use centralized logging that uses OpenSearch, AWS OpenSearch. So which is actually Elasticsearch version. And even the backup and disaster recovery is also most important in order to protect the data in case if any server crashes or some like that. So we can use Glacier for archiving the files, and then eBay snapshots. So these are the disaster requests. And Route 53 we can leverage in case if the primary zone fails. Route 53 can redirect the request to the secondary zone, which is a disaster. Which is a disaster. We can say disaster recovery zone. We can call it as a secondary zone. So in that way, actually, we can use this and provide our security and compliance.